This is Eureka Math, and we are in Module 5, Lesson 16. But we're shifting from the area of rectangles and the area of squares to now we're going to be exploring some different shapes and their attributes, okay? So that later we can find the area of different shapes that aren't rectangles and aren't squares. This is exciting because we haven't touched on any geometry yet this year. So this is definitely a geometry standard, which is one of my favorites. So let's get started. Our objective today is to draw trapezoids. Do you guys remember what a trapezoid is? Think back to 4th grade, okay? Here we've got squares, okay? And squares have the same size length on each side. And they also have the same size angle on each corner, okay? So that is a square. Those are the rules for a square. Same size lengths, same angles, and they're all 90-degree angles. I should have drawn that straight because those are 90-degree angles. So 90, 90, 90, 90. What's 90 times 4? 360, and we call those degrees, right? 360 degrees makes a square, because those are all 90-degree angles, so this is a square. Now, we're going to draw a rectangle, which is also has 90-degree angles. The difference is the rules for a rectangle is that only the opposite sides have to be the same length, okay? So double lines for those and single line for that. But they also have 90-degree angles, okay, which make 360 degrees on the inside. Now the difference between a rectangle and a square can be a rectangle, okay, but not all rectangles are squares. Does that make sense? Because a square has all the same attributes as a rectangle. It has these two sides are the same and these two sides are the same, and then these corners are all the same. So a square is a rectangle, but not all rectangles are squares, okay? Now, trapezoid, I'm gonna draw a classic trapezoid, but there's many ways to draw trapezoids. Now, trapezoids have at least one side is parallel, okay? At least one side is parallel, okay? That means that these angles don't have to be 90 degrees, okay? So this one is parallel to this one. That little check is a parallel, okay? So they don't have to be the same length. They don't have to, they don't have to be the same width, but they do have to, this line and this line do have to be parallel. Let's draw a couple more examples. We could flip it upside down, right? Still has 4 sides, but the angles aren't square. Can a rectangle be a trapezoid? Yes, it can, because the only rules are it has to have 2 parallel sides, at least 2 parallel sides. Can a square be a trapezoid? Yes, but not all trapezoids are rectangles and not all trapezoids are squares, okay? So those are our 2 angles there. Now I want to tell you something, even though these aren't 90 degrees inside here, right? Because this one is much smaller than 90 degrees, and this one's much bigger than 90 degrees. They're still 360 degrees inside there, okay? That's just a rule. All right, let's go to our Learn book. Please write your name on your paper. Draw a pair of parallel lines in each box. Okay, then use the parallel lines to draw a trapezoid with the following rule. Okay. So we're going to draw 2 parallel lines, and we can go any direction we want as long as they are parallel. And if you have a ruler, better. I don't have a ruler on my writing pad here, although I do have little dots. I suppose I could do a little bit better job. Let me try. Okay, let's see. So here's a parallel line, and here's a parallel line. Ooh, could you see that? Oh, I definitely do need to make sure that I stay inside the box though, huh? Okay, let me try one more time. Okay, here's a parallel line, And here's a parallel line. Did that come up? Nope. I really have to practice. This tablet has nice little dots on it, but I generally don't look at the tablet when I'm drawing. I generally look at what you guys are doing. Yeah, I'm going to ignore that for right now. Okay, so two parallel lines. Two parallel lines. Parallel line just means that they're on the same plane, that they go up and down or side to side or angle to angle. Oh, I look like a TikTok video. As long as they are always straight and parallel. They never, ever, ever going to touch, okay? So use the parallel lines to draw a trapezoid with the following. So this one says no right angles. And a right angle is a 90-degree angle. Okay, so if we have a square or a rectangle, they have 90-degree angles. They go straight up and straight down. They're perpendicular to each other. And this is a trapezoid with no right angles. So there and there. Are there any right angles there? Any parallel lines? No. So there we go. Only one obtuse angle. Okay, let's go through our angles. Do you remember? So here we have a right angle. Okay. Here we have an obtuse angle, which is bigger than 90 degrees. And here we have an acute angle, which is less than 90 degrees. So this is obtuse. This is acute. And this is a right angle. Do you remember this from 4th grade? Okay, so obtuse, like, is big, and acute is little. It's a cute little thing, and obtuse is a big thing, okay? So right angle is 90 degrees, obtuse is bigger than 90 degrees, and acute is smaller than 90 degrees. So only one obtuse angle. So how are we going to do this? Okay, we're going to start with two parallel lines. Okay. And there we go. This is parallel to this, just like this is parallel to this. And this angle right here is bigger than 90 degrees, but this one is smaller than 90 degrees. So there's our one obtuse angle, but what are we going to do over here on this side? They can't both be acute because this and this have to equal, this angle and this angle have to equal 180 degrees. They have to. That's one of the rules. All four angles together equal 360, and the two angles on one side have to equal 180. So if this angle is bigger than 90 degrees, this one's smaller than 90 degrees, I'm going to have to draw on this side something that is 180 degrees and 180 degrees. Two acute angles won't work, so I'm just going to go ahead and put two 90-degree angles. Okay, so it has only one obtuse angle. Okay, this one's going to be a little bit easier. Two obtuse angles. Okay, so here's a parallel line, and here's a parallel line. And this angle right here is obtuse because it's bigger than 90 degrees, and I'm going to draw a line here. And this one is bigger than 90 degrees. So these two are obtuse. I'm going to put O for obtuse. And this one is going to be smaller than 90 degrees, and this one's smaller than 90 degrees, so that's an acute angle. But I still have two parallel lines. In fact, I have four parallel lines. Okay. All right, at least one right angle. Well, we already did that in B, so let's see what we can come up with. How about so here's a right angle, at least one, so that means we can have more than one, and there's one. And then here is an obtuse angle, and here is an acute angle. So those are right, obtuse. I want to come back to this two obtuse angles. You know, I thought of another example, and I just want to make sure that you know that this would be a trapezoid as well. Okay. Look at that. There is an obtuse angle, and there is an obtuse angle. And this would be an acute angle, and this would be an acute angle. Okay? Okay. Use the trapezoids you drew to complete the tasks below. Okay, so we have 1, 2, 3, well, we actually have 5 trapezoids. Measure the angles of the trapezoid with your protractor. Okay, do you guys have your protractors? Do you know how to use your protractor? A protractor looks like this. Okay, and it has a spot there. And here it has all of the angles marked. So that's 90, and this is 180, and this is 0. And if you measure here, that's a 45-degree angle. And if you measure here, I'm sorry, this is a 45-degree angle. And this is halfway between 90 and 180, so that would be, hang on, 135 degrees. Okay? And then you'll have everything in between. Okay? So do you have a protractor? That's what they look like. They're usually plastic, and they usually have a hole in them so you can put your pencil here. And then there's usually clear or see-through so you can see what you're doing, okay? So measure the angles of the trapezoid with your protractor and record the measurements on the figures. I don't have a protractor at home to show you, but I just drew one, so I hope that that's a good explanation. Use a marker or crayon to circle pairs of angles inside each trapezoid with a sum equal to 180 degrees. Remember, I said angles inside a trapezoid. All 4 together have to make 180, but the 2 on either side make, 360, but the 2 on either side equal 180. Okay, list the properties that are shared by all trapezoids that you worked with today. Okay, all of what they're asking you for here in A is to measure each of these angles. They want you to put how many degrees, and I'm going to guess here because I don't have a protractor with me, but it's definitely bigger than 90, and it's probably closer to 135 degrees, and this is probably closer to 45 degrees. And what they want you to see is that 45 plus 135 equals 180, okay? Here, this one is 90 degrees, and that one's 90 degrees. And together, they make 180. Okay, so this is maybe 150, I'm guessing, and this would be 30, right? So together they make 180. They just wanted you to measure the angles, okay? So this one is an acute, and this one is an acute. So if this is 35 and this is 35, that would mean that these two have to be much bigger than that. They would be closer to, if they have to equal 180, that would be 145, okay, and 145. Okay, and here, this one and this one are 90 degrees. And if I were to measure this with a protractor, it's bigger than 90. It's probably closer to 130. And then that would make this one 50. Okay? So that was part A. Use your own measurements if you have a protractor, please. Okay? Degrees of each angle. All right. List the properties that are shared by all trapezoids that you worked with today. Well, they all have at least one set of parallel lines. Okay, that's one. Also, all of their inside angles equal 360 degrees, okay? When can a quadrilateral also be called a trapezoid? Okay, well, if the only criteria is that it has to have 360 degrees in it, then a square could be a trapezoid because it has this one and this one are parallel and all the angles on the inside equal 360, right? So this could be a square, yeah? A rectangle, if the only rule is that at least one side has to be parallel and the insides have to equal 360, well, a rectangle, okay? And of course we have this, when I think of trapezoid in my mind, I think of this, right? All right, so they have two parallel sides. Okay, so all rectangles are trapezoids, all squares are trapezoids, but not all trapezoids are rectangles, not all trapezoids are squares. Okay? Please be clear on that. Just like all squares are rectangles, but not all rectangles are squares. Okay? Okay. Follow the directions to draw one last trapezoid. Draw a segment AB parallel to the bottom of this page that is 5 centimeters long. Please get out your rulers and measure 5 centimeters, please. We're going to call that 5 centimeters. Measure it with your ruler. This is geometry. We can't just pretend. Okay? 5 centimeters long. Draw two 55 angles with vertices at A and B so that an isosceles triangle is formed with AB as the base of the triangle. Okay, so what is an isosceles triangle? Do you guys remember? Isosceles means that two of the sides of it are exactly the same length. This equals this, okay? This is an equilateral where all three are the same size. This is a right triangle where there's a right angle inside it. So this is a right triangle. This is an isosceles. This is an equilateral. Okay, that's just 3 for right now. Okay, draw two 55 angles with vertices at A and B. So vertices means the angle starts at A and B. Did they give us space? They did in your homework, good. Okay. All right, 250, so use your compass to find 55 degrees. And isosceles means they have to be exactly the same length. This one has to equal this one. And this is going to be 55 degrees, and this is 55 degrees. So we've done A, we've done B. Label the top vertex of your triangle as C, so there's C. Use your set square to draw a line parallel to A and B that intersects both AC and BC. So we want a parallel line that intersects means cuts in half, both A and B. And I'm going to use a different color so you can see it. Okay, so I'm going to intersect this at exactly the middle, right there. Ooh. That was not, see, I turned my head and everything so I could try and get it as even as possible. Use a ruler to line up your lines, please. Okay. Oh, and then it didn't stick around, did it? Okay. Oh, silly pen. So label the top vertex of your triangle as C. Use your set square to draw a line parallel to AB. So this and this are parallel. Do you see that? Okay, and now inside here we have a trapezoid and it says shade it. So I'm just going to shade it like that. And that is called an isosceles trapezoid. This is an isosceles triangle, and we drew an isosceles triangle, but then we drew a parallel line right there, and we made an isosceles trapezoid. Okay. Great. All right, there's your homework, and they gave you lines, which is much easier. So a trapezoid with exactly 2 right angles would have 2 right angles, but only 2, so you would probably want to do something like that. And then you have a right angle here and a right angle here. There, I just gave you the first one. Okay, and your exit ticket. Wheatgrass is grown in planters that are, wait a minute, just right. Sorry, ooh, that was 15, that one's from yesterday. 16 is here. Use a ruler and a set square to draw a trapezoid. Use a ruler, measure your sides, set square. Okay, set square looks like that. To draw a trapezoid. What attribute must be present for a quadrilateral to also be a trapezoid? Okay, attributes of a trapezoid. Okay, very good. Have a great day.